The Andromeda-Milky Way collision is a galaxy collision predicted to occur in about 4 billion years between the two largest galaxies in the local group the Milky Way and the Andromeda Galaxy, although the stars involved are sufficiently far apart that it is improbable that any of them will individually collide. Stellar collisions. While the Andromeda Galaxy contains about 1 trillion stars and the Milky Way contains about 300 billion, the chance of even two stars colliding is negligible because of the huge distances between the stars. For example, the nearest star to the Sun is Proxima Centauri, about 4.2 light-years or 30 million solar diameters away. If the Sun were a ping-pong ball, Proxima Centauri would be about 1,100 km away, and the Milky Way would be about 30 million km wide. Although stars are more common near the centers of each galaxy, the average distance between stars is still 160 billion km. That is analogous to one ping-pong ball every 3.2 km. Thus, it is extremely unlikely that any two stars would collide. Black hole collisions. The Milky Way and Andromeda galaxies each contain a central supermassive black hole, these being Sagittarius A and an object within the P2 concentration of Andromeda's nucleus. These black holes will converge near the center of the newly formed galaxy, transferring orbital energy to stars that will be moved to higher orbits by gravitationally interacting with them, in a process that may take millions of years. When they come within 1 light-year of one another, they will emit gravitational waves that will radiate further orbital energy until they merge completely. Gas taken up by the combined black hole could create a luminous quasar or an active galactic nucleus. As of 2006, simulations indicated that the future Earth might be brought near the center of the combined galaxy, potentially coming near one of the black holes before being ejected entirely out of the galaxy. Certainty. The Andromeda Galaxy is approaching the Milky Way at about 110 km per second. Up until 2012, there was no way to know whether the possible collision was definitely going to happen or not. In 2012, researchers came to the conclusion that the collision is definite after using the Hubble Space Telescope between 2002 and 2010 to track the motion of Andromeda. Andromeda's tangential or sideways velocity with respect to the Milky Way was found to be relatively much smaller than the approaching velocity, and therefore we expect it to directly collide with the Milky Way in about 4 billion years. Such collisions are relatively common. Andromeda, for example, is believed to have collided with at least one other galaxy in the past, and several dwarf galaxies such as SAG-DEG are currently colliding with the Milky Way and being merged into it. These studies also suggest that M33, the Triangulum Galaxy the third largest and brightest galaxy of the local group will participate in this event. Its most likely fate is to end up orbiting the merger remnant of the Milky Way and Andromeda galaxies to merge with it in an even farther future, but a collision with the Milky Way before our galaxy collides with M31 or being ejected from the local group cannot be ruled out. The fate of the Solar System. Two scientists with the Harvard-Smithsonian Center for Astrophysics stated that when, and even whether, the two galaxies collide will depend on Andromeda's transverse velocity. Based on current calculations, they predict a 50% chance that in a merged galaxy the Solar System will be swept out 3 times farther from the galactic core than its current distance. They also predict a 12% chance that the Solar System will be ejected from the new galaxy sometime during the collision. Such an event would have no adverse effect on the system, and the chances of any sort of disturbance to the Sun or planets themselves may be remote. Without intervention, by the time the two galaxies collide, the surface of the Earth will have already become far too hot for liquid water to exist, ending all terrestrial life. That is currently estimated to occur in about 3.75 billion years due to gradually increasing luminosity of the Sun. Possible triggered stellar events. When two spiral galaxies collide, the hydrogen present on their disks is compressed, producing strong star formation, as can be seen on interacting systems like the antennae galaxies. In the case of the Andromeda-Milky Way collision, it is believed that there will be little gas remaining in the disks of both galaxies, so the mentioned starburst will be relatively weak, though it still may be enough to form a quasar. Merger remnant. The galaxy product of the collision has been nicknamed Milkomeda or Milkdromeda. According to simulations, this object will look like a giant elliptical galaxy, but with the center showing less stellar density than current elliptical galaxies. In the far future, the remaining galaxies of the local group will coalesce into this object, that being the next evolutionary stage of our group of galaxies. See also, NGC 2207 and IC 2163, references. External links, Merrifield, Michael. Milky Way vs. Andromeda, the ultimate head-on crash. Deep Space Videos. Brady Heron A.